biologist, a pathologist, a cytologist will use the web-based viewer and annotating tools in the web viewer. But the data scientist, a bioinformatics, an AI developer will prefer to work in the terminal using Python and making applications. So here is where the magic comes. So in Cytomine, the viewer is just front end for your solutions. Python developer, an AI developer just need to have information, patches, mask, alpha mask, coordinates of annotations to train his models to be efficient.
Learn about the newest digital pathology trends in science and industry. Meet the most interesting people in the niche and gain insights relevant to your own projects. Here is where pathology meets computer science. You are listening to the Digital Pathology Podcast with your host, Dr. Alexandra Zhurov.
Welcome, my digital pathology trailblazers. Today's episode is about Cytomine, an open source software package for digital and computational pathology. This software can be used by pathologists, by AI developers, for image management, and basically meets the needs of many different parties working on digital pathology projects. And it's open source. My guest is Gregoire Vicky, the Chief Marketing and Business Development Officer of Cytomine. So let's dive into it. I'm going to welcome Gregoire. Welcome, Gregoire.
Hi, nice to meet you, Alexandra, and really thank you for this invitation.
I am so excited to have you. So I'm going to let you introduce yourself, but let me just give a little background story. And we have like a full agenda. We have 1 hour scheduled for this. And I have a list of questions that I need to ask you because they've been like, I was really thinking of different stuff that you have to offer and how you manage this, but nobody knows what I'm talking about. So let's start with Cytomine. Cytomine is the company that we're going to be showcasing, but how I even learned of Cytomine. So Cytomine, I have this blog post that is a pretty well-performing blog post on my digital pathology place where I list, I don't know how many softwares now, I don't know, 7 or 8, whatever, open source software for doing tissue image analysis. And I was updating this, and I think I updated with something. And then you guys reached out to me, or did I update with this? I don't remember. But somehow in the context of this this blog post, I included Cytomine as an open source tool for doing image analysis, but it's a different open source tool. And we have people from Algeria. Welcome, Algeria. Hello. It's a different tool. So let's do this. Let's start with you, Gregoire. Tell us about you, about your background, and give us a little bit of an introduction to Cytomine. What does it do and what is it for?
Okay. So quite like you, I guess I'm a vet on my initial formation, and I started working in research and toxicology and pharmacology also, but I was not a pathologist.
Where did you study for? Where did you do?
It's here in Belgium at University of Liège, where Cytomine was born. So I was firstly more working in pharmacology lab within the university, and I always had a geek side in my way of working. So in the end of year 90, the web was coming, and quite soon I was starting to develop tools to help research and teaching at university, and mostly in topics in bioinformatics, biostatistics, and histology already at this stage. And yes, my career has driven me into several Belgian universities where I had some kind of project in teaching and research with what we called new technologies. And in 2014, I was enrolled again at University of Liège to come to the Cytomine research group. And the Cytomine research group has been built by Raphaël Marais, which is the leader of this research group at University of Liège. And the team was dedicated really to the development of AI in the topics of digital pathology. So it was very specific.
When did you start that team? When was that?
Sorry?
When was that? When did you start?
The Cytomine team was built in 2010. And so Raphael and his colleagues start to develop Cytomine, and they start some research, publish the first algorithms and paper and so on. And I reached the team in 2014. So it was in 2014, and I was there to manage a project to use Cytomine also for the teaching aspect, because as a virtual microscope, it was really useful for teaching histology and pathology and cytology at university, and mostly in very big classroom, because in first grade there is more than 1,000 students a year. So
Oh, wow.
yes, it's massive.
School there.
Yeah. And then we start to work on Cytomine on this side, and then I became somehow the coordinator of this teaching project. And in 2016, the university have taken the decision to publish the source code in open source. So the open source adventure started at the University of Liège for academic reason. And when we start to publish the source code, Raphael and his colleagues has already published some papers that were quite well read by the community. So we have seen a flood of, I want this software, how do I install, I want it in my university, I want to teach with it, blah, blah, blah. And
all
then the university,
when there's a free software showing up.
The university says that, oh, you're supposed to be a researcher, not a software maintainer, not a community manager, so you have to make some choices. And then with part of the team, we decide to launch a company helped by the university, what we call a spin-off here in Belgium. Yeah. And then the entrepreneurial adventure started. Okay. This was in 2017.
So you said that Cytomine originated as a collaborative teaching tool, and this collaborative aspect, but it's also an image analysis tool. So the collaborative aspect of Cytomine was something that immediately caught my attention when we were talking, because it's such an important part of image analysis. Tissue image analysis, right? And digital pathology is super collaborative, or at least should be. You basically have people from with different expertise, and this caught my attention. So I think that was an unmet need that you guys were addressing when you started developing the platform. So why was it important enough to branch off of the open source model and create a paid enterprise version of the software? So this is something that
it's a large question.
Yeah, but I'm okay, is this open source or is this not open source? And you guys have two logo. The blue logo is for open source, and the non-blue is for the pink that you have behind is the commercial. Usually, you have the hardcore open source people that never want to have this cost any money, and there's plenty of effort going into it, but you have both. So you have both free and paid. What's the difference? Why do you have it like that?
So first of all, about collaboration. So the status we have made when we start to work in 2010 and then in 2014 is that if you want to collaborate within digital pathology, you must have a central place where all the data, annotations, logging, history, etc. is stored. And we were struggling because we were developing AI or giving teaching courses in digital and pathology, and we must ask the student to install desktop application on their own computer. So everything what they were doing remains on their computer. We do not have any feedback. And even if we want to develop an AI, for example, we will have to ask the pathologist with our hospital partners to annotate, export the annotation within the text files, send the text files, import the annotation in our own servers and try to work with it. And when the model is ready, send it back to them. No, it was very too heavy. So we decided that we will put everything on servers, and we have developed it since the beginning a web application. So Cytomine since the first day was always web-based. For this meanings that everything is centralized. So you get connected to the platform, you retrieve your data, you can see what your colleague have done, you see their annotations, you can see that it's your annotations, you can decide if you share them with the other people in the room, etc., etc. So it exactly the same when in teaching. So each student can get connected, have only access to the collection of slides the teachers want him to have access to. The teachers decide if the students are allowed or not to annotate or to follow the annotation of the teachers, and so there are a lot of scenarios that you can bring. So this is for what we call a collaboration. Collaboration means that people like of different level of expertise, student teachers, developer, pathologists, laboratory managers and pathologists and so on, have to share the same platform to be sure to be efficient, and that you have traceability, repeatability, and so on, everything which is definitely needed in research and teaching and in diagnostic. So this being done, we have published the code in open source, and the second part of your question is how do we manage this duality between the open source and the closed source. So it's a quite common model in the open source community. So
okay.
Yeah, it's a quite common. So
do we have somebody in the digital pathology community doing this as well, or like more other software?
There is a lot of projects which are open source but only academics. And there is some projects which are also open source and based on economic model, which is Omera with Glenn Koo, and others. So yeah, so it's not uncommon in the open source community. So a lot of software, you have a version open source which is allowed for you to get installed, to make it run on your computer, on servers, and start to work with. And the idea at the start of the company was, we met, so as it's a server-based application, we met a lot of teams that had struggled because they don't have servers to host the solutions, or they don't have enough storage in this on the servers, or they have the servers but they don't have the IT guys to make it run and to maintain and to correct when there is a problem and so on. So we sell mostly services. So at the start, we sell mostly services to install the solution on-premise on the IT infrastructure of the customer. So installation, configuration, we install the monitoring, we decide the rule of and the frequency of the maintenance, of the troubleshooting. We start also a lot of consultancy on how to prepare the rise of digital pathology in the different places where they acquire the solution, because as you may know, digital pathology is now very well known, but it's still in transition. So a lot of people still work with microscope, and generally when we come into a place, it's their first, but it's quite normal. Generally, people as just the first try in digital pathology, so we have to be a companion in this transition also. And then the number of customers were rising, and then we had also some struggle with open source, because, for example, if you want to add a new image format which is not open source, and you contact the company which has developed this format, and the company said, no, you are not allowed to make it open, you must build a plugin within your open source software, but the plugin is not open source. So quite soon, we were quite forced in some manner or another to develop some plugins, not open source, and we have an agreement with different people that we have going to sell this in this condition and so on. So we start to develop modules like that, but also Cytomine out of the box and in an open source version. If you download it and install it, you will see that it's quite normal. It's every step is manual. You can create a user by yourself and so on, but you will not spend times to create 1,000 users a year if you are in university. So we developed some closed source modules to add some features to the platform, for example, to automate all the authentication of the user within the company or the university, etc., or some tools to directly and automatically upload slides from a repository where the scanners are putting the slide, and based on the name of the slide, which is also depending on the barcode which is on the glass slide, directly upload it to the platform in the correct folder for the correct teacher or for the correct lab manager, and so on. So to make a lot of automation into the process, and these are also services that we sell within the company. And now we are ready to release in a few months our first enterprise edition. Will be a closed source, full distribution with a collection of new features that are really targeting, first of all, the sector of education, where we are quite active. Yeah, and then 6 months later for research. And within the company, we have taken the decision to target in 2 years to have a version dedicated to the hospital. So we have started the EVDR certification process and etc.
Oh, congratulations on that.
Or I don't know if it's because it's a long journey.
Congratulations on taking this decision, and good luck with implementation.
And so you open the question directly, and you will understood if you're gonna get certified, it's not the same game that building open source. So you have to fix your code, you have to describe every part of the code to be sure that it can be audited and so on. So also the closed source is also linked to the different certifications that we must attach to our software if we want it to be run into hospitals for management of image of patients, because our main motivation since the first day is to be an actor in the way to enhance the quality of the healthcare, and on our cases based on the digital pathology place and the rise of AI in this case. So within this strategy, it's not only based on the platform, it's also based about building a certified AI store in which we will be able to accept AI made by us for sure, but also by other companies that want to push their own AI into the Cytomine of our customers. So it's a global strategy which is based on these enterprise services. But once again, it's quite common if you look at some very well-known open source solutions outside of digital pathology. We have in Belgium here Odoo, which is a CRM, which is work on the same. If you have some Linux distribution, it's the same. You can have the open source version, but you can have services and extra products if you need, etc.
Okay, so two questions that I have. One is, so the open source is on premise and the paid one is cloud based. Is that correct?
No. Most of our customers are asking us to install on premise. So the big part
even
of
the one that is cloud.
Yeah. So
let's call the pink one is the one you pay for, and the blue one is the free one.
So most of our customers want to have, and it's quite normal because digital pathology slides are very sensitive data. So it's definitely not have to be hosted on the cloud. So we and they prefer generally to have it on their own server. But this is cultural. So it's in Europe, it's mostly on premise on the IT facility of the hospital, of the university, of the research center, and so on. In North America, in America in general, in Asia, it's more asking to host it on Azure or AWS. But once again, as soon as a server-side and web-based applications, the kind of hosting solution doesn't really matters.
Okay, so one here interruption. If anybody has questions, you can drop them right in the chat. I will be able to see them, and we can ask them, ask Gregoire immediately what is on your mind. So you have both. You have on-premise, you have cloud. Question to this, like if you. I was wondering this recently. It's not that you can, and I've heard it a couple of times, like if you are building something in the cloud, it has to be with the cloud in mind. It's not that you had the on-premise solution, then you like copied everything and like made it cloud compatible. You had to build a parallel tool that basically does the same. Is that correct?
I don't get the point, sorry.
You don't get the question. So, because many companies have on-premise software and then they're building like a cloud access. Is that easy? How does that work? Or do you have to have? So, can you like copy the on-premise software and just move it to the cloud, or do you have to develop
because the technology is the same.
Thing?
The technology is the same. When the IT facility of the customer, so the servers are just located in their own IT facility. But when you install it on the cloud, it just means that you install it on servers that are owned by cloud companies like AWS or Azure. But at the end, it's still servers. Whenever they are located,
you access it from the browser.
Yeah, every time.
Okay, now I understand.
No. So it's a only web-based application for the viewer part, and there you have the key of what we call the collaboration. Let me explain.
Yes.
A biologist, a pathologist, a cytologist will quite exclusively use the web-based viewer and annotating tools and managing data information in the web viewer. But the data scientist, a bioinformatics, an AI developer will prefer to work in the terminal using Python and making applications. So here is where the magic comes. So in Cytomine, the viewer is just a kind of front end that you may have for your solutions. You can have front end. We can say that somewhere a Python developer prefer to a Python developer, an AI developer just need to have information, patches, mask, alpha mask, coordinates of annotations to train his models to be efficient. And when he run his model on the image, he have to push back to the servers, the class he have done, the segmentation he have done, the identification, the countings, everything. So what we have done is Cytomine has an open API. So every component of Cytomine is speaking together, the DB, the database, the image servers, the viewer, etc., are speaking together within the open API. And we have made a Python client. So if you install on your computer the Python client of Cytomine, you will be able to get connected through Python to a Cytomine instance, ask for the annotation made by this user at this date on this collection of slides for this purpose, and it will send you the tiles, the classifications, the annotations, the coordinate, etc. You will be able to make your computational pathology, and at the end, you may send back to the servers the results to allow the pathologist to see it through the web viewer. So both communities, pathologists on one side and AI developer,
just build the perfect tool where the pathologist doesn't have to know anything.
I didn't say that, but that's why we are generally I hope chosen by communities. It's that it allows both communities to work in tools that are fit to their needs, and that's what we were doing at university. Because as AI developers and researchers, we need to have access to libraries in Python to make a lot of developments, and the pathologists with whom we were collaborating just need to see the image and verify in their own context if what has been generated by the AI really fits the context in medical information and etc. And they also need, because it was supervised learning at this time, they also need to annotate and to edit the annotation. You have made a podcast and a short video how to have efficient annotation for deep learning, for example. So you need to have good annotations. You have to correct them, to go back to validate them. So we built a system to peer review annotation. So for example, we have 10% in a project. We decide that they cannot see what the team's colleagues are doing. They annotate on the slide, and then after, let's say, 2 months, we show to each other the annotations of the other, and we cherry pick the best annotations after editing, and we are building what we call a reviewed collection of annotations, and only this reviewed collection of annotations will be used to feed an AI model, for example. So we have processes to be sure.
Talking about this, because people need to learn about this, about an efficient process. One question or one interruption. So just to be clear on what I was confused on, there is a web access to it, right?
Yep.
Cloud or server is just where the thing is hosted.
Yep, the backend.
So, yeah, backend. So frontend is the web. I put whatever Google address, URL, whatever. I go there, I annotate. As a pathologist, I don't have to do anything else than like take my mouse or whatever pen, tablet,
nothing to install.
Do my annotations. And
you just need to have the URL of the Cytomine you have access to, and just to remind your username and password. And even if you have a doubt, you take your tablet at home and you get connected to your Cytomine, and you see your image in emergency if necessary, and so on. So for example, for the student, it's the same. They can access the slide anytime from anywhere. So when I was a student in veterinary medicine, when we had histology classes, you and me, we were forced to be at 10 hours in room C in front of the microscope number 34 to have the collection of slide number 53. Now they just open the browsers. Now the students are in pyjama in their bed. They open the browsers and they work whenever they want, because on smartphone.
I learned some histology. Okay, and then 1 second.
Yep.
So then me as a pathologist, I don't care about the back end. I go in, I draw. The programmer or whoever knows how to code and has to code for this, build AI solutions, they don't have to deal with my coding inefficient browser for dummies. They can do their Python coding on their end, how they usually do, and this feeds into where I can later review.
And this is during the mostly during the model training or AI development process. And at the end, at the end, you have the pathologist which one day wanted to run themselves the tools that the developers have. So at the end of the process, we have a system that the developers can release the application within the Cytomine with a system which checks the version, so they can release different versions and we indicate which is the latest release, which is duplicated, the one you can use, they cannot use anymore. And as soon as you will run it from your web front end, you will define yourself your parameters that you want to sort, or the threshold, the numbers of image, on which image, etc. But on the database on Cytomine, we will know that Alexandra Durer have run this specific version of this app on this day, on this data with this parameter. So 6 months later, when I will see the results, and oh, do you remember this data set? It was so great. With which application has been built? I just look at the Cytomine. Oh, it has been run by Alexandra the 10th of November, and with these parameters on this collection of image, and I have my traceability, which is over there.
Hey, very quickly, this episode is also available on YouTube. This was a live stream we did with Gregoire. So if you're interested in viewing this, in addition to listening to this, join me on YouTube and subscribe to the channel. We are trying to pass the 1,000 subscriber mark. We are almost there at 966. So if you can help us cross this mark this week, I would very much appreciate. But now back to the episode. We need to do a demo. So this is just, podcast or discussion explaining this, but we need to meet again and you have to show me on video so that I can show people and we post it somewhere. If anybody's interested in the demo, put demo in the comments. So I will know that when we do the demo, you get the link to this demo. One more question before we go into another important thing, big picture, we're going to talk about that. But one question, you mentioned that this is also an image management system. Tell me how it's an image management system. And then tell me, with short steps, what are all the things that this software can do?
So what we call it an image management system is that for a Cytomine being able to provide an image to the web frontend or to the Python libraries for AI and so on, we need a system that can store and read these images. But what things that we are facing is we all know that an image in digital pathology is quite heavy. So we quite rapidly go into multi-gigabyte images and sometimes even bigger. During the biggest...
have some demo candidate, Dr. Siyu Yoon wants a demo, so good.
Okay, so for example, the biggest image we have faced is 100 gigabytes. So you understand mostly it's 1 or 6 gigabytes or 100 megabytes. But you rapidly face a situation where your disk are quite rapidly fulfilling. And then we make the system that an image is uploaded only once, but can be shared in a lot of different projects. And so we manage the right to the access to the image. So in Cytomine, by default, the image belongs to the users which have uploaded to it, because there is absolutely nothing public within the Cytomine. The assumption that we made, it's sensitive data. Once again, it's data that is used in research, in hospitals. It might be related to patients, so it's sensitive data. So the responsibility to have an image into the platform belongs to the users that has added it, and only him can add this image into different projects to allow other people to see them. So that's what we call an image management system. It's to manage the right of the access and who can put this image in project or put it out of this project and so on. But something which is really important, that never ever we transform this image. So everything which is done within Cytomine is just stored as external data within database. So we never ever transform the image. So if you publish an image into Cytomine and you come back 6 years later, you can load it back again. It will be exactly the same.
Mm-hmm. Great. So this is a huge requirement both for medical and veterinary pathology, especially for toxicologic pathology, that nothing can happen to this image. There cannot be any modification if you're actually evaluating your this for that diagnosis, and all the manipulation in terms of image analysis, masks, whatever you need to do for domain shift robustness. This has to be separate from the original one. So you guys have this covered.
Mm-hmm.
Okay, so you have been chosen as the provider, the software provider and the tool provider by no, I forgot to ask you again, what are all the things that this can do? So you can do annotations, you can build AI tools, you can deploy AI tools,
Yep.
you can manage images.
You can manage images. You can big applications which has, for example, data collections and data applications. So, let's say you have a project where you have 6,000 slides on which a lot of people have annotated for toxicology studies, for example. So, how many annotation I have with this category? How many annotation has been made within this time slot by this user from this location? Because main advantage, if you are, for example, a pharma company, you will have your testing in toxicology with rodents and so on in some countries, and maybe the scientists in another one, and maybe the drug development team in another country or another location. Everyone can access to the same platform, and the data are shared to everyone without having to move anywhere. So the slide remains on close to the laboratory stuff, and everyone can work on them and do some computational, some statistical, etc., etc. So in Cytomine, you can view, you can annotate, you can run applications, and this application can have AI inside, and there is no limitations in terms of technology of AI, because the strategies that we have, you can do your AI from anywhere in the world that can get connected through internet to your Cytomine, because then you can choose your technology, you can link into your GPU for training, and etc. And if you want it to be plugged into Cytomine, it will be isolated in Docker containers. So you can put the technology you want. You have the insurance that there is no conflict with the other application within the solution, because it's isolated with Docker containers.
Fantastic. This sounds really cool. So now back to big picture. So I already talked about big picture on several occasions, but just to recap this, a big picture is a private-public consortium in European Union, and the goal of this consortium is to build a huge image repository, both for clinical human pathology and for veterinary pathology, mostly for toxicologic pathology, to make a huge repository of slides where people can develop AI solutions on, or like do different stuff, but basically to have a huge repository. And you guys have been chosen as the software provider, as the software, all this stuff is going to be happening. So like, why did they choose you? How did this happen? And what are you going to be doing within this big picture?
So why do we have been chosen? Maybe you will have to ask to the management board of Big Picture. No, it's mostly because
I will do
that. Mostly because I guess we are server side and web-based, and this is definitely an asset when you have 46 or 47 participants spread over Europe, contributing from slides, probably contributing from AI, etc. I guess that's also because you can run your AI by connect your scripts to the solutions without any complication, and publish them after your AI within the solution quite easily. And also you can manage an unlimited size of image, because as it's server side, the limitation of number of images is only related to the size of your architecture behind. So I just have to correct that we are not the only solutions into Big Picture, for sure. So we have one of the tools that has been chosen, and specifically the tool which has been chosen for viewing, annotate, and run AI. Behind us, there is a lot of tools that have been put in place to store this petabyte of data, to manage the repository, to manage the permission of each user who has the right to contribute by giving some slide, by giving some metadata, by running some AI, by giving some code to read the image, and so on. So Cytomine is just a piece of a big puzzle.
Like you guys are the hub that everybody else connects to, and this then gets like
it's Cytomine will be the platform that will be launched when you ask to see a data set. So for example, you want to develop an AI on I don't know, and you want to you get connected to the repository. You see that within this repository there is a data set of images that may be interesting for your research. You ask to the consortium, can I have an access to the data set? And they will say, if they say okay, they will deploy a Cytomine just for you, and within the Cytomine you will have access to this image, and you will be able to annotate them to plug your AI to them and make your training and make your inference and at whatever you need. And at the end, you will have the choice to say, okay, everything what I've done, I want to share it with the rest of the big picture community, and you will be able to use Cytomine as a subscription tool. So now every annotation I've made, I want them to be added to the repository of big picture. So it will be a tool to see the data, to create some addition of data like annotation and classification and comments and whatever, and then push back them to the community of big picture.
So I know Big Picture has a work package on building the tools, not only using the ones that are already built. What do you guys need to still do, or are you ready as you are, or what?
We are never ready. There is always something to add. So first of all, you know that there is, let's say within brackets, a war in the digital pathology against the image format. So each scanner vendor has his own for a specific reason. Yeah, I will not take any position on any format, but there is a reason behind them. Some are targeting only the hospitals, or they claim, okay, it will be some seconds to have an image scanned. Some say, no, we are the best image in the world. We're targeting research, so the scan will spend 2 hours if it's necessary, but it'll be the best image in the world. Some are saying, no, we want to have Z-stack, some fluorescence, some blah, blah, blah. So there is a lot of reasons to have a lot of different formats. Each scanner vendor has his own specialty, etc. But within the project, it will be too heavy to start to manage all these formats. There is a claim that every kind of image that will be submitted will be transformed into DICOM. So we had to make the DICOM support for Cytomine. That every kind of AI application will have to respect this kind of format to be able to be uploaded. In some way, it will be quite close of the one we already use in Cytomine, but to be able to enlarge the possibilities, we will need to have some extra features. We'll also have some requirements in terms of way of showing the results, heat maps, and etc. So you have to expand the collections of a way of showing the results of an AI, depending of the AIs that have been built within the project, etc. And also, with the collaboration with the team dedicated to that, to be able to support the metadata model that has been specified by this community, and also the storage system that has been built within this community, because we are used to deploy Cytomine for our customers on their own IT facility with our rules of storage. But within big picture, with the numbers of partners that we have, we also have to take into account their own restriction, limitations, expectations, and so on. So we will have to make some adjustment on how does Cytomine manage a so big volume of image, so AI, annotations, permissions. It's because the permissions will not have to be defined by our own platform. We will have to mimic the permissions that has been ordered and given by the big picture consortium to say, give access to these people to this data with this permission, and do not give them the permission to run AI, for example, or do not permission, etc., etc. So there is a lot of, it's not building new features, but it's a lot of adjustment to make sure that the solution at the end fits the need of everyone within this project.
So it looks like there is no way around DICOM, as much as maybe some members of our community want to defend themselves from DICOM. And like you say, there was a reason behind every format. I just hosted recently a chat with David Clooney, who is the maintainer of the DICOM format. And we had an extensive chat about this DICOM for pathology, because radiology, that's a no-brainer. But in pathology, several people actually, in the context of big picture, are looking into it, are looking also how to support this on their end if they want to serve the pharma customers or the hospitals that are being part of this project. Okay, so good. No way around DICOM. So let's figure out how to work with DICOM.
Yeah, but I guess it's also a pain that is by the hospital sector, because within the medical imagery, it's used to work with DICOM since now more than 20 years ago. And they have all the infrastructure already. They have the culture of working with this format, and this format has a lot of advantages. But yes, we have to face the situation of one pathology images is very much bigger than the medical imaging one in terms of size in pixels, on the weight and everything. So sometimes I make simulation, and we can say that for one slide you sometimes replace 2,000 X-rays within the PAC servers.
Yeah,
So
I was
the difference is really huge, you know. So it means that the hospitals will have to manage not only the technology but also the storage and so the technical revolution there is a long debate, but definitely we have seen that more and more people are speaking about DICOM within digital pathology, and mostly because sometimes they are fed up about having so much different formats coming from so much different ways of acquiring image and so on, which has impact on how they store them, and to make them available for all the pathologists when there is a need for a patient care.
Mm-hmm. So I know this very much from the computational pathology community, where like a lot of resources is spent up front on managing the formats or on like writing scripts to convert one to the other so that they are all the same and that you can deploy something that actually will have some value for the patients in the long run. And they are fed up with that. They're like, we can spend those resources better. We can spend those resources actually on the end that has the potential to change something in the patient outcomes
Yes,
or make stuff more efficient. We don't want to spend time managing your image formats. So,
and you have this struggle within the digital pathology workflow. But when you think a second about AI development, we in the community, we can see that there was a fear against AI a few years ago. But now what I felt when I going into conference is that I see pathologists that really understood that AI can be a companion within their daily work. But if we want to have powerful AI, we'll need to train them on a large collection of image, and you know that. But if everyone can share the image, have images in different formats with different characteristics, and that your AI tool within Python and script doesn't have a free reader of a free way to read these images, we will not be able to train this AI. So the problem there is we might face some AI only trained on this specific format, and so link in the way in another to a format of image. And scientifically, people will prefer to open the range of the different data sets that will be able to use to train the AI, or on which they will apply the AI for better care. So it's a debate. It's a long debate. It's not the role of Cytomine to take position in it, but what we've seen is that there is a lot more and more discussion within the community to go in the direction of DICOM. And within the big picture project, it has been a decision that every slide stored in the repository must be in DICOM.
I love the name of their tool, the DICOMizer. I love the DICOMizer. Yeah. So yeah, you say it's not your role to, express your opinion, but you definitely have to adjust to all the requirements. And what you have been telling me are the requirements of a massive project. It's like a 6 year or 7 year?
6 year.
6 year project that has like millions of investment, many stakeholders. So I am super curious.
Yeah, it's a really great experience within this project. It's very enthusiastic.
Yes. Okay, so we need to schedule a demo because I want to see, like, for me, for example, if I wanted to do annotations, I have to just like open a browser and go to this repository where I should do annotations on, right?
You're right. So the first step, you need to have a Cytomine installed up and running, and as soon as it's up and running, you just open your browser, you put the URL of the Cytomine you have been provided to, and you put your login and password, and you can to work.
So can I get this? we can take it offline, but I would like to. Let's see, maybe we can do some testing or whatever.
No, so indeed we have a demo instance in the company, so people are free to ask for a demo account, and we will provide them a demo account on which they can get connected and try the solution and to see if the solution fits the needs. Because it's covered the community of image analysis, and when I say image analysis, it includes analysis by humans on image. It's not only computational analysis. It covers so many topics into biology, into cytology, histology, pathology, etc. So the best way is to test it. So if you wanted to have your own, you can follow the documentation. So you can go to doc.cytomine.org, and you have a freely accessible documentation with a user guide, how to install it, and etc., how to develop your own Python script. Documentation.cytomine.org. And but you can also, if you don't have the skills or don't have the time or whatever, you can ask to the company with info@cytomine.com, and please provide me a demo account because I want to do this and this and test if you are compliant with this and this, and I will create your account, and you will be able to test the solution.
Okay, so maybe I'm gonna do that. I'm gonna send this email, and then next time we meet and you like
You're
walk
welcome.
me through everything. Let's see if we could do that, because definitely people would want to see it, see what the capabilities are, and it's just seems like a very good tool for an institution, like a multi-site institution. And I think a lot of institutions are facing the challenge, okay, this site has this tool, but this site invested in a different tool. How can we meet? How can we work
Yes,
together?
and the biggest experiment we have made in this topic is University of Liège now is launching a few days ago the 12th edition of a MOOC, so a massive open online course on histology. The first edition were in French only, but now this actual edition, which is on open, is also in English. And there we have, from the different courses, it's 1,000 users spread over the world that can get connected and explore the slides, make annotations, follow the exercise, and see the video from the teachers and so on. So they can open the microscope, virtual microscope Cytomine whenever they want, from whenever they want in the world. And so, yes, for a multi-located company, or you see that we have seen that more and more hospitals are joining force to make consortium. It's also the same in research. If you want to have a grant for research, for example, it's quite impossible to have it if you don't collaborate with distant organizations, and more they ask you to have collaboration with university outside of your own country, etc., etc. So for
you have
this
like
kind of
preferred countries, some partnerships from less privileged countries, then you get extra points, and then you have.
So let's say, for example, we have a project where the university hospital here in Liège will provide the slide, but the computational part will be taken by a university, for example, MIT. They can work in the same platform because it's server side, and the computational developers can do their work within Python using the Python library, and the pathologists can open the web front end whenever they want, from whenever they want at home or during Congress or whatever, to see the image, to annotate, to make the review, and so on. So yes, it's a main advantage to be web-based. You can work from everywhere.
I want to test it. I have this one video on YouTube, like how to annotate in ImageScope, and I want to do a similar one, how to annotate in Cytomine. It's like, I don't know,
for example,
5-minute video or 10-minute video.
You are
And
welcome.
a lot of people are looking it up, so I definitely want to explore. Okay. Next step, we schedule a demo, and I let everybody know that there is going to be a demo. Thank you so much for joining me, Gregoire.
You're welcome. Thank you so very, very much to give us this opportunity to speak with you. And it was a real pleasure before, during, and I guess after this podcast. You're really a shining people.
Oh my goodness. Thank you so much for beautiful words about me. But we're going to be in touch because I think your tool is cool and I want to explore it more. And thanks everyone who was here. Let me know if you were here live or if you are watching the replay. And if any questions come to your mind when watching the replay, let me know as well, because we're going to be addressing them. And this is the place to ask them. And I can relay them to Gregoire directly. Okay. Thank you very much.
You're welcome. Thank you very much.
Thanks so much for listening to the episode, staying till the end. If you liked what Gregoire was talking about, and if you like open source software, you will love our next initiative. We are having a series of webinars about open source software. Actually, about a set of open source software packages called HistoSuite tools. This is going to be a webinar I will be hosting together with Andrew Janowczyk, the author of the HistoSuite tool package, and the most famous of his software tools is HistoQC. That was the first one he invented. So if you are tired of sorting through all kind of stain variations, slide preparation, and scanning artifacts manually in your pathology image datasets, or if you're afraid that the trend you identified in your image data is actually a reflection of a batch effect, or maybe you just want to stop wasting time on useless annotations and know exactly which patches are relevant for your model development. Or if not that, how about keeping your H&E staining consistent in your lab? Any of this resonates, applies to you, this webinar is a must, because there are free tools to solve your problems, those HistoSuite tools. There's going to be a link to register in the show notes, so be sure to go there, click and register for this webinar, and I would love to see you in the audience so that you can explore those free tools to solve a lot of your problems. That's why there is a whole bunch of those tools. And Andrew is a fantastic speaker. He's hilarious, super entertaining. So no matter if you're super advanced and you're interested in the code, or you're new and want to just know about the applications, he's going to be able to explain it in a super clear and really entertaining way. I am very excited about this webinar, and I will love to have you there. So click the link to register, and I talk to you in the next episode.